Let's take another look at the problem of predicting Pennsylvania state standardized test scores when we had no other information. We said we could just make a prediction just as one number and use that everywhere, and then record the mean absolute error and the root mean squared error. And we said we could try different numbers here. We could try like 1200, we could try 1250, etc., 1300 maybe. And for each of them we can record the mean absolute error and the root mean squared error and see what prediction gives us the best values there. And I mentioned that we could do that using a what if data table, so I'm going to walk us through that right now. That's a handy skill. It's not really useful here because we know what the answer ends up being, but it's a good skill to have. So here I've set up a table with a bunch of different prediction values that I want to try. And I'm going to record the mean absolute error and the root mean squared error. So to do that, I'm going to put here an equal sign and click on the mean absolute error cell. And then I'm going to do the same thing for root mean squared error. And then I'm going to tell Excel to basically pick up this number, put it there. It'll get used for all these predictions. Then it'll compute these two, it'll copy them here, and then it'll copy from here to whatever number it had just used. So it's kind of like, it's going to go through all these systematically, kind of like a for loop. So the way I'm going to do that is I'm going to highlight, it's kind of weird, I have a blank cell here, I have all the numbers I want in this column, all the numbers I want to try, I have the stuff I want to record over here, and I'm going to highlight all that, and go to data, and then what if analysis. Sometimes all that's showing here is just a question mark, and I want to do a data table. And because I've got my different values laid out in a column, I'm going to specify the column input cell is this right here. So we're telling it, take these numbers from this column, input them there into that, and then it will know to read the values at the top row and paste them in there. So I'm going to hit OK, and it does all that computing for us. And what's the next thing we want to do? Probably graph it. It gets a little confusing to do those, so I'm just going to highlight all this stuff and graph it. And we can see that, let's see, series 1 was the mean absolute error, series 2 was the root mean squared error. And we can kind of eyeball where the lowest values are. Let's zoom in on the chart here so we get a better look. Maybe it looks like both values are between 1300, well, let's go like 1290 and how about 1320, and then we'll also zoom in on the y-axis 60 to about 90. We can see a little better. Still kind of hard to see. Let's zoom in on the mean absolute error to begin with here. Zoom in vertically. So let's go from just 60 to maybe 67. And there we can see that the minimum, there seems to be a slight upslope here, so the minimum is happening at 1310. And what would you describe as the shape over here? It actually looks piecewise linear. That's kind of interesting, rather than a smooth curve. And then let's zoom in on the root mean squared error vertically. So that was between about 80 and 90. And that looks pretty smooth. Let's zoom in even more, maybe 85. So that's looking like the root mean squared error is minimized somewhere around here, which is about 1308. And not coincidentally, the average of the data set was 1308 point something. So I had mentioned that the mean gives the lowest possible root mean squared error, and I think we just kind of saw that that's at least plausible on the graph. And what is the 1310? It turns out that's the median of the data set, and that gave us the minimum possible mean absolute error. One more thing we can try let's compute the MSE. I said that's maybe not as useful sometimes as the root mean squared error, but it's kind of interesting here. So let's compute that, and then we'll graph all the things we tried versus the mean squared error. And let's fit a trend line to that. What kind of trend line would you guess would be a good one? Looks reasonably polynomial, huh? Maybe power order 2. And we'll show the equation in the r squared. And we get an r squared of 1, which means that the data fits the parabolic trend line exactly. I know it's hard to see the parabolic trend line here. Let's fix that up. Okay, so the mean squared error as a function of our prediction is exactly a parabola. So that's kind of interesting. I should emphasize that that doesn't always happen. That's just when we're doing this kind of prediction where we have just a bunch of individual values rather than doing a regression.